I think there was an alternative way for me to draw out the impact of friction with this physics lesson, and it didn't occur to me till after the lesson, so I thought I would take a look at it now. Here is the graph of the second activity, where the students collected accelerations and applied forces, and then we crowdsourced our data and got this great, terrific linear graph with an incredible r-squared value, close to 1. The slope looks like it is, 6,000 divided by 600, or that's the ratio anyway of those 2 points, but it looks like it goes through the origin, so that sort of looks like a slope of 10, which is terrific, but maybe a little premature in terms of celebrating because, we know that it's a net force, not an applied force, that it should be related to the acceleration. So there should be a little offset down here where there would be no accelerations until we overcome a frictional force. So we're going to zoom in on that. Here's the exact same data that my students collected, and the best fit line that was drawn in. You see it's not touching any of those data points, but the larger numbers of the data set are kind of driving the best fit line function. But here you can see that best fit line coming right down through and having a y-intercept of just a little bit less than 20, which is pretty satisfying since the frictional force that was reported on the simulation was 19.6 newtons. So I used the Google Spreadsheets utility called Advanced Edit Features, and you can change the range of your y and x axes so that you can sort of zoom in on a section like this. Pretty satisfying to see that frictional force wind up right there. Had I been a little more quick thinking in class, I might have been able to show that right away to my students, but maybe you will.